The map that proves humans explored Earth 5,000 years too early. Why does a 1513 map show coastlines nobody should have known for centuries? And why do some parts line up with modern charts far better than they should? Most people think it's hype, but the weirdness is real. Here, that's what actually happens when you look closely. We're going to stress test the claims, separate myth from fact, and follow Piri's own notes. There's one detail that forces the timeline open a crack. Hold that thought. If you care about what humans really knew, earlier than we admit, you need this. The artifact on the table, what the map is. Okay, so here's the thing. Piri Reis wasn't a random scribe. He was an Ottoman admiral, a working navigator, and a compiler. In 1513, he assembled a world map on gazelle skin parchment and later presented it to Sultan Selim I after the Ottoman conquest of Egypt in 1517. Only a third survives today in the Topkapi Palace Museum. The Atlantic in the middle, with Europe and North Africa on the right, and the Americas on the left. The fragment also shows an extra southern landmass hugging the bottom. More on that later. Piri filled his map with notes in Ottoman Turkish. He says he compiled it from roughly 20 source maps and charts, Portuguese rudders, Arab maps, 8 Ptolemaic pieces, a chart attributed to Columbus, and others he doesn't name. That's the first key. He's not claiming invention, he's claiming curation. He pulled together pilot knowledge from several empires, some of it already old, some of it jealously guarded. What kind of map is it? It's a Portland-style chart, a pilot's tool, not a scholar's globe. You see compass roses scattered across the vellum and a spiderweb of windrose lines radiating in 32 bearings. Those rumline networks are classic Mediterranean navigation tech, great for holding a constant bearing from cape to cape, less great for representing the whole world's curvature. There's no latitude, longitude grid drawn, no formal projection graticule, and almost no inland detail, because it wasn't meant to be a land survey. It was meant to help you not die at sea. Now, what does it get right? For its time, the South American coastline on Piri's fragment is surprisingly coherent. Brazil's bulges there. Major river mouths show up near where you'd expect. Certain capes fall roughly where they should by latitude. The Caribbean, though, is a mess in places. Features of Cuba and Central America get fused together. Hispaniola borrows personality from Marco Polo's Japan, and island chains are exaggerated. That's a known Columbus-era artifact. Early pilots misidentified Cuba as a mainland and carried that error forward. In other words, we see fingerprints of specific source maps embedded in the collage. People get stuck on impossible accuracy, so let's be precise. In 1513, nobody had a reliable seagoing method for longitude. You could estimate latitude decently with the noon sun, a cross staff, or an astrolabe. But longitude was a headache until accurate chronometers in the 18th century. Without a clock, you fudge east-west distances. Portland's got around this by chaining bearings and distances from known capes and ports. Over short ranges, that works well. Over an ocean, distortions creep in. So when a 1513 compilation shows an extended coastline with fewer east-west distortions than you expect, you have to ask why. Piri gives a clue in his marginalia. Some sources were ancient maps, with no recent hands correcting them. That's vague but intriguing. Greek to Arab to Ottoman transmission, possibly. We know classical and medieval scholars measured Earth size, built star catalogs, and calculated latitude. We also know seafaring nations, Portuguese and Spanish above all, treated accurate charts as state secrets, the Padrão Real and its equivalents. So a working admiral with access to captured pilots and copied rudders could plausibly assemble a mosaic more advanced than any single public map. But here's where it gets interesting. The mathematics hidden in the ink. Even without a formal projection, portlands have a geometry, a consistent windrose network, a scale of leagues, a web of bearings. If Piri copied coastlines that were themselves derived from better baselines, reliable distances logged on repeat voyages, astronomical fixes on landfalls, then the collage could inherit that underlying structure. That's the central claim we'll test. Does the Piri fragment preserve a geometry beyond what 1513 methods alone produce? Let's calibrate expectations. A typical early 16th century Atlantic sheet nails the Mediterranean and West Africa, centuries of Portolan refinement. It sketches a fairly convincing Brazil up to a point. Portuguese pilots were already coasting there. Then as you slide south or sweep around the bulges and bays of South America, shapes warp, compress, or yaw because longitude drift multiplies. The far south gets guessy, and the Caribbean carries Columbus's misreads. Piri's fragment does some of that, There are honest errors. The Amazon's bulge is oddly handled and some tapering looks off. But certain southern segments sit too neatly against modern coastlines to dismiss as luck, especially given the era. That's the itch researchers can't quite scratch. If the map is a copy, whose geometry is it copying? Remember, Piri wasn't just reading libraries, he was hunting intelligence. Ottoman fleets captured charts, interrogated pilots, and traded knowledge with North African corsairs. In that world, a cartographer admiral wasn't just drawing, he was synthesizing rival state secrets. So here's our plan. We'll walk through the 1513 longitude problem. We'll fit South America segment by segment, no cherry-picking. We'll tackle the Antarctica claim carefully with glaciology in hand. And we'll take Piri's source notes seriously without buying myths. If there's advanced mapping here, the clues sit in the alignments, in projection artifacts, and in the consistent errors only a shared template would create. Mapping without longitude, the 1513 problem. Here's what actually happens when you try to map an ocean in 1513. Latitude is doable, longitude bites you. Pilots could pin latitude with the noon sun using a cross staff or an astrolabe, or with Polaris when it was visible. East, west, though, you're estimating. Without a precise marine clock, which no one had until the 18th century, you can't convert time difference into degrees. So navigators chained legs, steer a bearing, hold it for so many leagues, correct for wind and current, then reset at the next landmark. Over short stretches, that's fine. Over thousands of miles, tiny errors swell into warped coastlines. Portolan charts evolved to make that chaining efficient. The Windrow's web, 32 bearings radiating from compass roses, let you plot constant courses as straight lines. It's elegant on a local sea. It's not a globe. Draw enough legs and the misfits add up, especially when you splice multiple voyages. That yields a signature look, coasts that feel right up close but drift in orientation and width when you compare them to a modern grid. Now here's why your eyebrows go up with Piri's fragment. Most early 16th century Atlantic sheets nail the Mediterranean and North Africa. West Africa is decent thanks to Portuguese routines. Brazil is recognizable near the bulge. But as you sweep south, east, west distances usually compress, parallels tilt, and big arcs lose their true swing. On Piri's sheet, certain South American runs resist that drift more than they should. Not everywhere, but enough that you notice. So how could anyone do better without a chronometer? Two practical workarounds existed. First, repetition. Sail the same coastal legs again and again, log leagues and average bearings. Redundancy tames noise. Second, astronomical anchors. If shore parties took good latitudes at prominent capes and distances between those capes were measured repeatedly, a compiler could lock long runs to those anchors, normalizing the segments in between. It's not true longitude. It's longitudinal logic, shape preservation built from disciplined inputs. There's also the magnetic problem most people forget. Compasses point to magnetic north, not geographic north, and declination varies by region and time. Portolans encode that bias as a systematic rotation. If you copy sources from the same workshop or zone, you inherit the same tilt. If you mix zones, you get clashing orientations. On Piri's South American mid-latitudes, you see a remarkably consistent tilt across multiple bends, as if they were lifted from one geometric parent rather than stitched from random scraps. That's a fingerprint of a template, not an accident. Okay, but what about scale? Portolan descendants often show east-west squeeze along parallels. When you compare Piri's mid-Brazil coast against modern charts, the distances between recognizable features run short by a nearly uniform factor. That uniformity matters. Random scraps give you variable squeeze. A standardized shop doctrine gives you the same squeeze everywhere. Apply one rotation to correct magnetic habit and one scale to undo the squeeze, and long stretches snap into a plausible overlay without elastic warping. That's the test. A lot of Piri maps from the 151s fail along extended coasts. Let me ground that with a quick micro story. A modern cartometrician digitized Piri's coastline from near Cape São Roque down toward the Rio de la Plata, stripped labels, and ran a rigid transform. One rotation, one uniform scale, one translation. The middle segment, Bahia through Cabo Frio and beyond, settled with tighter residuals than typical early 16th century compilations. The fit degraded near the Amazon bulge, and at the far south, exactly where coverage was weakest at the time. That's not proof of perfection. It's evidence of a strong but incomplete spine. Now this is important because it tells you what to look for. Consistency, not miracles. The hallmarks of a disciplined pre-chronometer map are predictable. You'll see enlarged estuaries and gulfs, navigators inflate safe water. You'll see a steady rotation born of magnetic declination in the source zone. You'll see uniform compression along parallels because leagues ran short on paper. And you'll see error clustering at edges where survey density thins. Piri's fragment checks those boxes in the mid-latitudes. Everything changes when you add incentives. Portugal and Spain centralized their best data in crown atlases, the Padrão Real and the Padrão Real, and treated them as state secrets. Pilots, rudders, and soundings fed those offices. Journeyman chartmakers applied house corrections so copies shared a look. Same tilt, same scale, same exaggerations. Public maps lagged, operational sheets stayed locked away. If an Ottoman admiral with access to captured pilots and copied charts compiled a world sheet, he could inherit that hidden geometry without ever seeing the master atlas itself. You might be thinking, couldn't this just be good luck and artistic smoothing? Not with a single transform steadying hundreds of miles while preserving relative spacing between capes. You can fake a couple of capes by eye. You don't fake proportional inter-cape distances across 3 bends without a disciplined backbone underneath. So here's the working model for 1513. Latitude anchors from the sky, distance baselines from repeated coasting, bearings from a consistent magnetic habit, and a chart house smoothing overlaps into one spine. Piri didn't solve longitude. He didn't have to. He copied a geometry that behaves as if someone else had already done the heavy averaging, and that's exactly the kind of quiet advancement a monopoly would hide and a captured fragment would reveal. The South America fit test. All right, let's stop speculating and run the coastline like a navigator who has to make land by dusk. We're going to pick anchor points you can't fake by artistry. Prominent capes, unmistakable bays, and big river mouths that a 16th century pilot would log without hesitation. Then we'll force a rigid cartometric test. 1 rotation to correct magnetic era tilt, 1 uniform scale to address league compression, 1 translation to place it. No rubber sheet cheating. Anchor set 1, the Brazilian bulge. Lock Cape São Roque as the salient, then use the Reconcavo All Saints Bay near Salvador as the first deep indentation south, and Cabo de São Tomé / Cabo Frio as the southward swing markers. On the Piri fragment, those features appear in the right sequence and at plausible latitude spacing. When you apply a single rotation consistent with early 16th century declination in the South Atlantic, the mid-bulge shoreline sits down with fewer outliers than peer planispheres of the 151s. It's not pixel perfect, but the inter-cape distances compress by a nearly uniform factor, exactly what you'd expect from a standardized league scale, not a collage of random sketches. Anchor set 2, river mouths. We're not chasing tiny estuaries. We're testing the São Francisco's Notch, the Paraíba do Sul's coastal approach, and the yawning bite of the Rio de la Plata. The Amazon is where the fragment underperforms. Its convex bulge is flattened and slightly displaced. That's a known weak coverage zone for the era and a natural casualty of projection by eye. Slide south and the São Francisco's latitude lands close to expected, and the coast between Salvador and Cabo Frio holds a steady azimuth once you've corrected rotation. Drop to the Plata and you see the navigator's bias. The estuary is over-enlarged for safety, but its center line and the opening's orientation tie neatly into the next bend. The exaggeration is human, the geometry beneath it is disciplined. Now the uniformity test. If you need to keep tweaking scale section by section, you're just forcing a fit. Here, a single scale factor stabilizes the run from roughly Bahia through Cabo Frio and into the Santa Catarina stretch. Residuals cluster, and the misses aren't random. They spike at the Amazon arc and at the far south where early Iberian coasting was thinner before the mid-16th century. That clustering pattern, order in the heavily sailed middle, noise at the lightly covered edges, is the signature of a shared coastal spine being extended with weaker gossip data at the ends. Let's talk angle behavior because this is where artful guessing usually collapses. Take successive chord segments between identifiable features, say Salvador to Cabo Frio to Santa Marta. Measure each segment's bearing after you correct the global rotation. On the fragment, those bearings oscillate around a stable mean bias rather than wandering. Oscillation implies repeated runs averaged into a house angle, wandering screams stitched scraps. The fragment oscillates. Patagonia is the surprise overperformer. After 1 rotation and 1 scale, the sweep from roughly the northern Patagonian coast into the San Jorge Gulf aligns in both relative position and turn angle better than most public charts from the 150 ones. The gulfs remain inflated, predictable Portolan DNA, but the spacing between headlands tracks modern coastlines with that same uniform squeeze. If you've ever tried to force a speculative coastline to match modern geography, you know it usually breaks at the bends. This one holds shape across multiple bends. Counterpoint time: could later Portuguese surveys explain it all? Early coasting along Brazil ramped up fast after 150, and crown chart houses synthesized aggressively. That's our point. The fit implies a state-grade template existed by 1513, and that Piri accessed its geometry indirectly, through captured pilots, copied rudders, or partial tracings. You don't need miracles. You need a disciplined office smoothing multiple voyages into a standardized tilt and scale, then a compiler who preserves that discipline. Let's quantify without drowning you in math. Choose a dozen robust features: 4 capes, 3 large river mouths, 5 major bay inflections, across the bulge and down to the Plata. Fit the fragment's polyline to the modern coast with 1 rotation scale translation. Now examine residual distances from each historical feature to its modern counterpart. On the Piri segment, median residuals sit notably lower than on several contemporaneous public planispheres. Interquartile spread is tighter. Outliers hug the Amazon arc and the far south. That distribution isn't what you get from good art. It's what you get from a common measurement doctrine surfacing through a copy. Projection clues back this up. The latitude spacing behaves like a pseudo-equidistant mindset. Latitudes respected first, east-west averaged by leagues, while the room line lattice pins bearings in a magnetic frame. The combination yields 3 consistent fingerprints: steady rotation across the entire run, uniform east-west compression along the same latitude band, and navigator-centric exaggeration where shelter mattered. All 3 appear together on the fragment's mid-latitudes. So what fails? The Amazon bulge, predictably, certain far south tapers where survey density thins, and inland fidelity, because portolans don't care about inland. What stands? The proportional spacing between mid-coast capes, the preserved swing angles across multiple bends under a single transform, and the tidy clustering of errors where 1513 coverage was weakest. Here's the simple read. If you can stabilize hundreds of miles with 1 rotation and 1 scale while preserving inter-cape distances and bend behavior, you're not looking at luck. You're looking at a spine, likely Iberian, compiled behind closed doors, that Piri managed to echo. The Antarctica question carefully. All right, the southern landmass. On Piri's fragment beneath South America, there's a long, angled coastline running nearly east-west along the bottom margin. It sits far too close to Patagonia for a true polar continent, and it's drawn as one continuous shore instead of scattered icebound segments. That proximity is why this gets controversial. Squint, and a few curves feel like the Antarctic Peninsula. Step back, and it also reads like the era's standard, unknown South land, stitched on to balance the map. So 2 lanes. 1, it's Antarctica. 2, it's Terra Australis, the traditional South Continent cartographers added for symmetry, seasoned with rumor from high latitudes. The Antarctica lane claims the map shows an ice-free coastline, implying observations thousands of years old. The Terra Australis lane says it's conceptual geography guided by extending Patagonia and echoing old cosmographic ideas. Which one survives a hard check? Let's start with what advocates assert. They say certain sweeps align with the Antarctic Peninsula and Queen Maud Land. They cite a Cold War-era analysis that supposedly matched Piri's coast-to-sub-ice seismic profiles from the late 194s. They argue you don't invent those shapes in 1513. It's a tidy story, but tidy isn't the same as testable. Here's what glaciology and cartometrics actually give us. Antarctica's interior and most margins have been ice-covered for many tens of thousands of years. After the last glacial maximum, the broad Holocene trend was thinning and retreat in parts of West Antarctica, not a wholesale re-advance that would recently hide clean rock coastlines. Even where shelves collapse, the grounding lines remain deep. You don't get a neat, ice-free rim mirroring modern topography around the whole continent in the last several millennia. So the 6,000 year ago ice-free coastline premise doesn't fit the big picture. Now the geometry. When you constrain overlays honestly, 1 rotation, 1 uniform scale, no elastic warping, the supposed matches fall apart. Promontory spacing is wrong. Gulf widths don't track. The drawn line is at the wrong latitude relative to Piri's own South America, practically kissing Patagonia. And the coast behaves like an attached skirt continuing a familiar arc, not a separate polar mass. That's classic Terra Australis behavior. Renaissance maps by Scherner and Orance Finet did similar things, sweeping southern shapes with confident crenellations unmoored from measurement. Piri's line joins that club. What about the famous Air Force analysis story? The claim is that a U.S. team in 196 found a close match to a 1949 Swedish-British seismic transect under the ice. There's no transparent peer-reviewed paper demonstrating that overlay with explicit transforms and error bars. It survives as an anecdote in popular retellings. Meanwhile, when scholars put the fragment through cartometric tests, the southern line fails neutral constraints and looks conceptual. If there were a robust match, we'd have reproducible methods, not folklore. So what are we actually seeing? A composite informed by tradition and rumor. Navigators heading south out of the Atlantic reported colder seas, icebergs, strong westerlies, great birds. Compilers extrapolated, extend Patagonia's bend, smooth the unknowns, inflate possible gulfs the way Portolan practice always did. Remember, the same hand that drew a tight Brazilian spine also enlarged the Rio de la Plata beyond reality. Navigational exaggeration is part of the craft. On the Southland, that habit runs the show without the anchor of real survey data. You might ask, then why do some curves feel familiar? Pattern hunger. Given a long, smoothed line and the freedom to rotate and rescale mentally, our brains snap to nearby shapes. But the map doesn't just need vibes, it needs constraints. On those, the fit doesn't hold. There's one detail in Piri's notes people like to wave at. The line about day length, short nights, long days, reported by a Portuguese infidel in far southern latitudes. That's not Antarctica, that's high-latitude sailing culture. It tells you the pipeline included crews who noticed seasonal extremes and used astronomical tables. It supports disciplined northern and mid-southern observations, not polar cartography. So here's the grounded read. The southern coast on the fragment is Terra Australis logic, not Antarctica. It's too close to Patagonia, too smooth, and too unconstrained by measurable anchors. It inherits Portolan DNA over wide gulfs, confident lines where none were surveyed, and the era's cosmographic urge to balance land with land. That doesn't make the fragment less interesting. It clarifies where the map is strong and where it's speculative. And that distinction matters for our bigger claim. If you want to argue for a hidden coastal template, don't hang it on a polar mirage that fails glaciology and cartometrics. Hang it on the measurable mid-latitude coherence we just tested. The same page can carry both, disciplined geometry where fleets sailed and a traditional skirt where they didn't. Knowing which is the whole game. Piri's source notes, the lost library angle.